Welcome to this deep dive into disk partitioning, where we explore the differences between MBR, the master boot record, and GPT, the GUID partition table. Why does disk partitioning matter? It explains why you might encounter issues like not being able to use a large 4 terabytes drive, having a limit of only 4 partitions, or why your operating system refuses to boot. The answer lies in the partition table. A partition table is a small data structure at the start of a disk. It describes how the disk is divided, showing where each partition begins and ends, and what it contains. Without it, the operating system only sees raw sectors, no drives, volumes, or file systems. We have two competing schemes. MBR, introduced in 1983, is the legacy, limited, and simple option for BIOS systems. GPT, introduced in 1999 as part of the UEFI specification, is the modern, flexible, and robust standard. Let's take a closer look inside the master boot record and how these 512 bytes boot your computer. The MBR lives in the very first 512-byte sector of the disk, known as Sector 0. The BIOS reads this sector, finds the boot code, and hands over control. Everything that follows, from partitions to the operating system, starts from these 512 bytes. The MBR is only 512 bytes, divided into 3 regions. 446 bytes are dedicated to boot code, 64 bytes form the partition table with 4 16-byte entries, and the final 2 bytes are a boot signature that the BIOS checks. Each partition entry is exactly 16 bytes, containing 6 fields. The LBA start and LBA sectors fields are the most critical, using 4 bytes each to tell the OS exactly where the partition begins and how large it is. The MBR's 2 terabyte ceiling is due to its 32-bit logical block addressing. With a standard 512-byte sector size, the maximum addressable space is approximately 2 terabytes. Beyond this, the pointer cannot reach the remaining space on larger drives. The partition table has only 4 entries, limiting the number of primary partitions to 4. If a 5th partition is needed, the table is full. The workaround involves using an extended partition, which can then contain multiple logical partitions. The MBR has 1 copy and 1 chance. If any of the 512 bytes in Sector 0 are corrupted, the OS can no longer locate your partitions. There is no checksum, no backup, and no recovery metadata. In summary, MBR has hard limits, a maximum disk size of 2 terabytes, only 4 primary partition entries, a single 512-byte sector, and 0 checksums for corruption detection. These constraints, which made sense in 1983, are why MBR is being retired today. Now, let's explore the GUID partition table, the modern UEFI era replacement for MBR. GPT was created by Intel for the EFI specification in the late 1990s. It replaces BIOS boot code with UEFI firmware that natively understands partitions. The table itself can describe massive drives with full redundancy. The GPT layout includes a protective MBR and LBA 0 for compatibility with older tools. It features a primary GPT header and partition entries at the beginning of the disk, with a full backup copy at the end for redundancy. Partition data resides in the middle. Sector 0 still holds an MBR, but it's deliberately misleading. This protective MBR presents itself as one huge hexadecimal EE partition covering the entire disk. This deception prevents old MBR-aware tools from seeing unpartitioned space and accidentally destroying the true GPT. The GPT header, located on Sector 1, acts as the map to everything. It is 92 bytes of critical metadata. Key fields include the EFI part signature, the header size, the disk GUID, and the backup LBA, which points to the backup copy. Crucially, header 32 Costa Rican colons ensures integrity. Each GPT entry is 128 bytes, 8 times the size of an MBR entry. They include a 16-byte partition type GUID to identify the purpose, a unique partition GUID, 64-bit LBA start and end sectors, attribute flags, and a partition name up to 36 UTF-16 characters. GPT uses 64-bit LBA, offering a massive increase in addressable disk space. The maximum theoretical disk size is 9.4 zettabytes, compared to the MBR's hard limit of 2 terabytes. This new ceiling is effectively limitless for modern storage needs. The standard GPT reserves space for 128 entries, which is 32 times what MBR allowed. While the specification technically allows for more if they fit in the reserved space, most operating systems keep the default at 128 partitions. GPT is self-healing due to its dual-copy architecture. If the primary header is corrupted, the firmware detects the 32 Costa Rican colons mismatch. It then reads the backup copy at the end of the disk, verifies its integrity, and rewrites the corrupted primary data, recovering the system without data loss. GPT directly addresses MBR's weaknesses: a 9.4 zettabytes max disk size via 64-bit LBA, 128 default partitions, full primary and backup copies for redundancy, and 32 Costa Rican colons integrity checks everywhere. These features provide more space, more resilience, and greater safety. Let's put MBR and GPT side by side to compare their technical specifications. MBR is capped at 2 terabytes max disk size and 4 primary partitions, using 32-bit LBA and a 1-byte type code. GPT supports 9.4 zettabytes and 128 partitions with 64-bit LBA and 128-bit GUIDs. GPT includes 32 Costa Rican colons, integrity checks, and a full disk and backup, features MBR lacks. MBR relies on BIOS, while GPT uses UEFI. MBR booting relies on BIOS post, which reads Sector 0, checks the hexadecimal 55AA signature, and executes the MBR boot code to find and jump to the active partitions loader. GPT booting is handled entirely by UEFI, which reads and verifies the GPT header and entries, then loads an EFI executable directly from the EFI system partition. No boot code is needed on Sector 0. In terms of operating system support, 64-bit Windows, macOS, and modern Linux can all boot from both MBR and GPT, provided they have the correct firmware. However, 32-bit Windows cannot boot from GPT, only MBR, though it can use GPT as a data disk. GPT booting requires UEFI firmware. If your system has UEFI, use GPT for larger drives, more partitions, and superior data integrity. If your system is BIOS only, or you need compatibility with old 32-bit Windows or very old systems, stick with MBR. MBR to GPT conversion is possible and non-destructive on systems like Windows 10 Plus using MBR2 GPT.exe or Linux using gdisk. GPT to MBR conversion is destructive, requiring deletion of all partitions first, and the resulting disk is capped at 2 terabytes. Downgrading is rarely necessary or recommended. To recap, MBR is a 512-byte header limited to 4 partitions and 2 terabytes. GPT adds GUIDs, 64-bit LBAs, 128 partitions, and 9.4 zettabytes capacity. GPT offers self-healing via CRC checks and full backups. Ultimately, the choice depends on your firmware: UEFI for GPT, BIOS for MBR. In 2026, GPT should be the default. Thank you for watching this deep dive. If this video cleared up MBR versus GPT for you, please subscribe for more deep dives into storage, networking, and the internals of your PC. See you in the next one.